often you'll get your data in more than one file. So maybe that'll be data for 2018 from 2019, 2020, and so on. Or it might be for different locations, or it might just be that you've got one data set about crime rate and another data set about GDP or something along those lines. And you want to pull them all in the same time. So I was going to just do that process, but I thought I would do it live so you can see me making mistakes and trying to work out how I will solve them. So I'll try and go sort of slowly through those mistakes and explain them. I've got a new notebook here and I've imported pandas. That's all I've done so far. I have the data I've got over here in a folder, and let's have a crack at loading it up and having a look. So let's just say pd.read CSV, and then we can, as that pops open, we can see the docs for it. We can have a look through it, and we're just going to put in for now just their path. So we can copy relative path there, paste it in as a string. Okay, it didn't find that. Oh, it's because it's a backslash, because Windows hates everyone. So still know what's going on there. Is it dot slash? This sort of thing is kind of a mystery sometimes. So okay, let's work out where we are. I think it's because I haven't saved the file. Pandas is hating me this morning. I've got the newest version of VS Code at the moment, so maybe yours doesn't look quite like this. Okay, so now this file properly exists. Right, and we'll give it a Python. Now we're talking. There we go. Okay, that's better. So let's have a look through what we're dealing with here. We've got 2,500 rows. They're all on the same lake. Date, time, which is nice. We've got the lake name, site ID. So these are all categorical. It looks like that's going to be the same all the way through. The conductivity varies, the temperature varies, and the milligram DO, I guess that's density, milligrams per liter. Now these are all kind of going to be tricky to work with, particularly this temperature one, because it has a degree sign in it, and Pandas is struggling with that a little bit. But we can rename them as and when. The easiest way to do that is actually just to we just edit that by hand. So let me show you how to do that. So we'll just call that df, because that's a kind of Pandas convention. So we say df.columns. Okay, so we can just grab that list and we can say df.columns equals, and then so I can format a cell by Shift Alt F. So those are all fine. Estuary, let's make that estuary name, take the space out. Sample depth, we'll take that M out, we'll take the conductivity data out, take the temp thing out, and we'll leave that. And let's change DO to density. Now, just because I'm like pedantic, I'm going to go through and change all of these to lowercase, because otherwise they'll get confused in my mind with classes. Alright, so now we can do new cell. We'll just do it here actually. So df dot sample okay, so that, oh there it goes. I wonder why that didn't work. Alright, now we've got all of those things. The columns are much more usable. We can access them more directly, so we can say something along the lines of df dot date time, and we can see we've got this. Now what would be interesting to find out is what this is. Has it automatically converted itself to date time? It doesn't look like it. Let's have a look. Looks like it is a string. So I'm going to look up I can either look up the docs for this, or I can look in the file, the example file. I'm going to look up the docs. Pandas read CSV. Alright, so there's a kind of bewildering array of stuff here, but we'll just look down and see which one gives us dates. Parse dates. Okay, inferred date time, blah blah blah. So it's going to be down here. Okay, parse dates. So that we can either say true, parse all the dates, or we can give it a list of columns. So we can just say parse column whatever 1. So in our case it's actually parse column 1. So what's the parse dates? So we can say comma parse dates equals, and then which column is it? It's the first column. So maybe that's 0. Let's have a look. There we go. So now we've done that, and it's now a date time rather than a string, which is much more useful if we want to plot time series data, because if you plot time series data with a string, you get evenly spaced ticks, even if the time points aren't evenly spaced. Alright, so the reason we're doing this is we want to have a decent understanding of what the data is like before we try and import a whole bunch of it. So let's do a quick look at what it looks like. So df.temp.plot, and that'll give us just a nice line plot of the temperature. So that's cool. That looks pretty legit. Like it's doing some things. Now that data is evenly distributed. So that we see along the bottom here, that's the number of samples, and so we want to, if we want to do that more nicely, we can say dot set index, and then we want to set the index on date time, and then if we plot that, so that temporarily changes. Oh, it's a series, okay. We need to, okay, yeah, I got it. So we need to set the index before we pull the thing out, because, okay, so df is a data frame, df.setIndex on the thing moves that across to be the index, and then it becomes a time index, and then we pull out the temp column, and then we plot it. So this now looks a little bit more, a bit less nice, but a bit more believable, right? So it wasn't being continuously sampled, it was being sampled with much like rarer frequency. So now we get a date index kind of automatically, and then this on the left is the that's the temperature. So got really hot for a couple of days, which is weird when you're half a meter under the water. It's 30 something degrees. That's like very bizarre. Then we had I guess a bit of time where someone was measuring the temperature, and then a bit of time where someone was measuring the temperature, and then you get these big gaps where no one was actually doing anything. And then we had this big drop. So the temperature below the surface and above the surface is a meter apart, which is a pretty big deal. Alright, so we know that the data looks okay. Let's also on the same plot density and see if it makes any sense. So we can say, we can just copy and paste that, and then have a look at that. So yeah, that makes sense, that the data for density matches the data for temperature. Like the sort of readings were roughly at the same time. So that's cool, that's good. If we wanted to get fancy, we could put them on different axes, we could do all sorts of stuff, but I feel pretty confident that this data in this table is okay, and we're good to read it in. So what we would do here is say, okay, we've got one data set that's coming in here, and we want to pull in the other one. Now, we've got the LC and the ML. There's two ways we can do this. One is by explicitly just copying all of this stuff and doing it again, which is fine if you've only got one, but I'm pretty sure this data set is actually like 20 odd. And so you'd want to load them in more explicitly. So what we want to do is, let's do this in stages. So we'll say file name equals, and then we'll pull this bit out, and we'll put it in there, and we'll make an F string. File name, F string, just check that it still works, good. And then what we really should be doing here is using the path library, which allows us to join things together in a sort of operating system safe way. So we'll put the folder in there, lake data, and then what we can do is we can say os.path.join. Now we're going to need to bring in the OS library as well. So now the operating system will join, the Python will join those two files, the bits of that path together in the way that we want it to. So we say import OS. Now we've got that, it works. It still loads the stuff. Just check for that. Yeah, so we're all good. So what we're seeing here is I'm changing stuff, but I'm changing the code, but I don't want the outcomes to change in any kind of useful way. Right, so now we've got a way of importing one file. What we really want to be able to do is import all the files in that folder. So OS, playing is really low. I think that will just show. There we go. Okay, so os.listdir lists the stuff in the directory. It gets a bit complicated because it lists folders as well as files, and so like bulking a directory is a bit of a complicated thing, but for the moment we're fairly simple. It's only got those in it. So what we can do here now is loop over that to load up the files. So we can say all data frames equals a list, and this is the same pattern we've been doing for weeks now. So for df in, no, not df, for file name in os.listdir, and say print file name. So when we run that, it prints those two file names. But what we really want to do now is say we can drop this file name here, get rid of that because we're getting that from the loop, and we can cut this and we can make the data frame inside the loop, and we can put that in there, and we can, okay, so that's it. That's everything we're doing to load that stuff. So now we can say all data frames dot append df. So now we're making a list and we're filling it with data frames. There we go. So you see how that was a little bit slower. Now if I look in here and I type all data frames, then I've got two data frames basically. Now that's all very well, but we need to join those two data frames together, and if we do that we won't know where that file came from. So one thing we're going to do, we'll mush all the data together. We won't know which file the data came from in the first place. So one thing we'll just do is say df source file is, and this will just fill the whole column file name. So that will fill the whole column on that data frame with the name of the file. So I'll load it up and have a look at this one. So now there is a source file column. If we just look at the first data frame so it's a bit clearer, there's now a source file column that says, okay, this came from the LC file, which means that we can like trace back to where we were looking to begin with. Now, there's a bunch of different ways we can join a data set. This one is fairly simple because we just want to basically stack them on top of each other. So that's going to be a concat, and there's a lot of discussion about how to do that. So data frame concatenate, let's have pandas. Okay, so merge, concatenate, and compare. So some of these things are joining them like left and right, some of them are joining them top and bottom. There's also kind of helpful data examples here. So concat is a super simple one. It just takes these three data sets, or however many you want, and then just puts them together because they all have the same number of columns and the columns are the same, so it understands how to stack them. So we're in that situation. So actually all we need to do is this pd.concat, and that will give us what we want. So you can have a read through that. It's a little bit more, there's a lot to learn in there. So pd.concat all data frames, and we run that and we get this mega data frame. So we can see estuary lake name, different, it's a different lake, so it's good. So what we want to do there is say for lakes df equals that, and I'll say all lakes df dot sample. Let's have a look at them. Cool, great. And we can see that they are clean. They're coming in with the LC for Lake Conjola and ML for Meru Lake, and we can do a very dirty but interesting potentially graph of that and say, well, let's change that from DF to all lakes DF and see what happens when we plot that. So this doesn't really make any sense in the sense that we're plotting the temperature of different lakes as a single time series. We should really be splitting them, but that would all make sense. So let's split them and see what happens. So we can do that with a group by. Now, we haven't talked about group by yet, but I was going to do it in a separate video, but we might as well because we've got some good data here. So we can say all lakes DF dot group by, and we need the name of the thing, so estuary name. Group by estuary name. Now if we run that, we get a group by object. Group by objects are sort of complicated to understand, and it's really taken me a long time to get to the point where I really understand it. So let's just be kind of clear about this. So it's for name, and that's the name of the group. So we'll see what that is in a second. And then DF. So what we're dealing with here is a sort of unpacking double thing. What's the error there? Oh, yeah. There we go. So there's two things here, and they come out as unpacked things. So let's print name, comma, df dot shape, and we should get, there we go. So that's the name, Lake Conjola and Meru Lake, and there's 2,600 and nearly 2,700 data points in Conjola and 2,600 in Meru. Okay, so we can just steal this from here and chuck it in here, and this, we need to change that back to DF. And there we go. So that's doing the 4 different lines, so we can see how they relate to each other, and they're kind of interesting, but I don't know which is which. So I think we can set a label, and we'll say let's call this temp, and then we'll f string in the name of the thing, and we'll call that one density. Now that again didn't do anything because we have to say plot dot legend. Oh, we haven't imported plyplot, so we have to go up here and import it. So what we're seeing down here, the error message is name plot is not defined, and so import matplotlib dot pyplot as plt. I think that's right. It's one of those things that you do so rarely. Okay, let's run that. Alright, so that's a weird place to put the legend, but cool. So now we've got the legend for this, which allows us to understand what it's talking about. So the temperature of Lake Conjola is the blue, and the temperature of Meru is the green one. So interesting that Meru doesn't track Conjola quite so well. So this would be a good time to get a map of those two lakes and see why they're different. Are they at different altitudes? Which one's one shaded more than the other? And then we can see the density changing. Like, is there a correlation between the density and the temperature? I'm not sure. So we could do a scatter of that potentially. So you can do all sorts of things with this data, but what you're going to see, I guess, is that the number of groups in your group by doesn't matter so much because you're dealing with it in a loop. So once you've loaded all of the data from your folder, you can do this and it will just like buzz through all of it and you'll be able to see what's going on. And so that's the simplest way of doing a data join using a concatenation. You will be able to do joins in a kind of databasey way based on a column or based on some sort of common piece of information which we would call a key in the two data sets. So let's say you've got suburb name or postcode in two data sets and you want to join them together, maybe you can do that. But that would be a thing to have a little read up on, and if you need a bit of help with it, let me know and I'll make another video if you can find some data sets that you want me to try this out on. Okay?